In this video, I'm going to find the reduction formula for integration sine to the power mx cos to the power nx dx, where m and n being any positive integers greater than 1. Okay, so I'm denoting this as I to the power mn integration sine to the power mx into cos to the power nx dx. So this cos to the power nx dx I'm writing as cos to the power n minus 1 x into cos to the power x dx. Okay, so this I have written in this form. So this I'm taking as the first function, this I'm taking as the second function. Okay, this I'm taking as the first function, and this I'm taking as the second function. After that, I apply integration by parts. For integrating this part, okay, so for integrating this part, I have taken t as sine x. So I took t as sine x. So I differentiate this with respect to x. So we get dt equal to cos x dx. So in place of t, here sine x I wrote as t. So we get t to the power m. Cos x dx is dt. So this I have written as dt. Now if I differentiate this, I get n minus 1 cos to the power n minus 2x. Differentiation of cos is minus sine x. Okay, differentiation of cos we get minus sine x. And integration, same way as before, we get t to the power m dt dx. Okay, so we have here cos to the power n minus 1 x. So if I integrate this with respect to t, we get t to the power m plus 1 divided by m plus 1. So here we have minus into minus, we get plus. Integration n minus 1 cos to the power n minus 2x sine x. And here we get t to the power m plus 1 by m plus 1 dx. Okay, so m plus 1 is a constant and n minus 1 is constant. It will come out of the integration, so we get this. Now you replace here t with sine x, so we get here sine to the power m plus 1 x by m plus 1. So we get here plus n minus 1 by m plus 1 integration cos to the power n minus 2x sine x, and here we get sine to the power m plus 1 x dx. Okay, so if we add this to sine, so we get sine to the power m plus 2x. So we get here sine to the power m plus 2x. So we can separate this by exponent law. So we get sine to the power mx into sine square x. Okay, so we get this. So sine square x can be written as 1 minus cos square x by using the identity. So we get here this. So then you multiply this one with this and also this one with this. So if you multiply here, okay, so this we can add the power of cos. So if we add the power of cos by exponent law, we get cos to the power n minus 2 plus 2. So that is nothing but n. So we get here cos to the power nx into sine to the power mx. That is nothing but imn. So here we get here I to imn. Okay, so this will be imn. So this side also we have imn, and here also we got imn. Okay, and here you can see that this is also in the same form, but here the power is reduced. So we get im n minus 2, because the power from n, it has reduced to n minus 2. So we get here im n minus 2, and here it is same. Okay, so we get n only, so this will be replaced with I to mn. So here we have imn, here also we have imn, so we'll bring this one to this side. Okay, so we get this. Okay, so we get this. So we have here we have imn. So bring this one to this side. So we get plus. So we get, now you can take imn common. So we get this 1 plus n minus 1 by m plus 1. Okay, which is equal to this. We get this. Now if you do the LCM, we get here m plus n by m plus 1. So you multiply throughout with m plus 1. So m plus 1 will be cancelled everywhere, and you divide through, okay, and divide throughout with m plus n. So we are getting this. You multiply this thing throughout with the reciprocal of this. That is, you multiply throughout with m plus 1 divided by m plus n. So m plus 1, you multiply m plus 1 divided by m plus n here also same. So we are getting this. So this is the reduction formula for this. Similarly, if we convert in different forms, here I have applied here for cos. Okay, so if I do the same thing for sine, so if I take sine m minus 1 x into sine x cos to the power n x dx, then we get the reduction formula to be this. Okay, we get the reduction formula to be this. So we are going to use both. So this is the reduction formula for the same thing, but in if we convert, if we take, for this one we have obtained by taking cos to the power n minus 1 x into cos x. But if we take here sine to the power m minus 1 x into sine x, then we get this reduction formula. Now we'll try to find the reduction formula in terms of 0 to pi by 2 for this only. So we have already got two reduction formula for this. So we'll apply the limit in this two reduction formula. So if you apply the limit 0 to pi by 2 in the first reduction formula here, so pi by 2 will, this part will contribute to 0, and 0 will contribute, this 0, the limit 0 will give you this part will contribute to 0. So both the upper limit and lower limit will contribute to 0. So we are left with only this. So here the reduction formula will be only this. Okay, so we get n minus 1 m plus 1 m plus n j m n minus 2. So this is the reduction formula for up by using the first reduction formulas. So in the same way we can use the reduction formula, the second reduction formula also. So we get here this, so we have this. So if I put pi by 2, this part will contribute to 0, and if I take 0, this part will contribute to 0. So in both the cases, the upper limit and lower limit contribute 0. So this part is 0, so we are left with only this. So we have m minus 1 divided by m plus n j m minus 2n. So we get this same reduction formula for the same thing. Now we try to solve this one. Okay, so integration for sine x cos square x. So we are using the reduction formula. So I'm using the second reduction formula. If you can see here, I'm using the second reduction formula, that is imn equal to minus sine to the power m minus 1 x cos to the power n plus 1 x divided by m plus n plus m minus 1 divided by m plus n I m minus 2 n. So I'm using that. So here m is 4, the highest power is m, so m is 4. So I'm using the second formula to make it smaller the power. Okay, so I'm using this. So we get sine 4 minus 1 x cos to the power 2 plus 1 x divided by 4 plus 2. And here n is 4, so m is 4, so 4 minus 1 divided by 4 plus 2, I 4 minus 2, comma 2. So here we get 3 by 6, here we get I 2, 2. So here m is 2. Now we'll apply the same formula here. So we get minus sine 2 minus 1 x cos 2 plus 1 x divided by 2 plus 2 plus 2 minus 1 divided by 2 plus 2. I 2 minus 2, comma 2. So here we get 0. Okay, 0, 2. Now here n is bigger. Now we'll apply the first reduction formula. So we get here sine 0 plus 1, okay, x cos 2 minus 1 x divided by 0 plus 2 plus 2 minus 1 divided by 2 plus 0 I 0 comma 2 minus 2. So we get here 0. So we get I 0 0. So here the I 0 0 is nothing but the power of sine as well as cos is 0. So this part will give you 1, and this also will give you 1. So we have to integrate only dx. So if I integrate dx, I get here x. So we have 1 by 16x plus integration constant. So we get here 1 by 6 in x plus integration constant, where c is the integration constant since it is an indefinite integral. And we try to reduce this reduction formula for this. Okay, so we have here 0 to pi by 4 sine 4 x cos to the power 8 x dx. So we use the first reduction formula because here the power of cos is bigger, so we'll use the first reduction formula. So we have I for 8. So 8 minus 1 divided by 4 plus 8, I for 8 minus 2. Okay, so we get 6. So here m is 4, n is 6. So again we'll use the first reduction formula. So 6 minus 1 divided by 4 plus 6, I for 6 minus 2, we get 4. So Here also again we go with n only, so we get 4 minus 1 divided by 4 plus 4, I4 comma 4 minus 2, we get I4 2, n become 2 here. Then again we'll go with the same formula, so we get 2 minus 2 divided by 4 plus 2, we get I4 2 minus 2, which is 0. Now when we have to go till we get 0, then we use the second reduction formula here. So if I use the second reduction formula, here we get 4 minus 1 by 4 plus 0, I4 minus 2, 0. So we get 3 by 4, I2, 0. So again we use the second reduction formula, so we get 2 minus 1 divided by 2 plus 0, I2 minus 2, comma 0. So we get I0, 0. So here the power of sine as well as cos is 0. So this part will contribute to 1. So we have to integrate only dx. So if we integrate dx, we get x. So we apply the upper limit and lower limit. So we get here pi by 2 minus 0. So we have here pi by 2. After that, you just multiply this. We get here as 7 pi divided by 1024. Thank you.